last problem in this section starts out by telling me a random sample of 1,800 observations from a binomial population produced x equals 576 successes. You wish to show that p differs from 0.3. Now the first thing it actually asks me to answer is to calculate the appropriate test statistic, but I need to know my null and alternative before I go any further. So even though it doesn't actually ask me to do this, I absolutely would always create a null and alternative because I will need to refer back to them. In this case, if I'm looking to show p differs from 0.3, p is not equal to 0.3 would be my alternative, and p equals 0.3 would be my null. Again, the question isn't asking me to fill those in, but I will need to know what this symbol is in order to understand how to interpret the p-value I get below. Here, when it tells me to calculate the appropriate test statistic, I'm going to start by finding p hat, in this case 576 divided by 1,800. When I put that into my calculator, 576 divided by 1,800 gives me 0.32. I then find my z-score by taking that 0.32, subtracting 0.3, and dividing it by the root of 0.3, 1 minus 0.3 over 1,800. Parentheses, 0.32 minus 0.3, and parentheses divided by the root of, parentheses, 0.3, and parentheses, new parentheses, 1 minus 0.3, and parentheses divided by 1,800, and parentheses outside of the square root. I should get as a z-score 1.85. That 1.85 now gets converted to a p-value. So I go onto my sheet, I look on the positive side for 1.85. 1.85 takes me to a p-value of 0.9678. It's now time to look back at the alternative hypothesis. When it says to calculate the test p-value, I need to base it off this alternative. If the alternative had been less than, I would just keep whatever the p-value of my test is. If the alternative had been greater than, I would just do 1 minus this p-value and keep that as the p-value of the test. The hardest way is the way it is here, if I have a not equal to alternative. In this case, I have to consider, am I on the right or left side? Since 1.85 is positive, it's on the right side. Since it's a right-sided value, I need to do 1 minus this p-value of 0.9678. When I do that, I get 0.0322. That would be my p-value if this was a greater than test. Because it's not equal to, I also have to consider that same area being on the left side. That's why I have to do 2 times 0.0322, which gets me to 0.0644. That is the correct p-value for this two-tailed test. Now that I have that p-value, I need to compare it to an alpha of 0.05. 0.0644 is greater than 0.05, which would tell me because the test statistic is greater than alpha, I fail to reject. It then asks me, does that agree with what I would get using 1.96 plus or minus as a rejection region? So they're saying negative 1.96 starts this side, 1.96 starts the right side, and I want to compare my 1.85. It would fall here in my fail to reject region, so using regions of rejection, I would get the exact same answer as using the comparison of p-values. It then asks me, should they agree? Absolutely every time. There are 2 ways of looking at the same thing from different vantage points. No matter what, the conclusion I get here when I compare p-values should always agree to the conclusion I get here when I compare to regions of rejection. Assuming that I'm using the same alpha or level of confidence, they must agree. If I changed from alpha equals 0.01 to 0.05, for instance, then they could disagree. But as long as I'm using the same method with the same alpha, they must give me the same answer.